myself, Lauren Gardner, Emily Gross, and Veronica McCracken have been part of this effort to do a better accounting of embodied carbon on the interior. And Lauren and Emily are with me here today, so they will speak about different parts of it. But as a background, I wanted to give a little history. So for the last couple of years, we've been working on this sustainability metrics sheet that goes in the beginning of our drawing set. We developed it to track performance, and we found that one of the best places to do that, to keep it routinely in front of project teams, is to have it actually in the drawing set. So it's aligned with the COPE Top 10, or the Framework for Design Excellence. And so if you hear us talking about the G sheet in this presentation, that's what we're talking about. And here in the little diagram section is where we account for project embodied carbon. And in fact, we have a little conversion graph that we made, so you can look at embodied carbon stacked against lifetime carbon, which adds up year after year, or operational carbon, and get a lifetime carbon number. And essentially what we realized is that as we were filling this sheet out for a number of different projects to test it out, we realized that we didn't have good data on some of the interior materials. And as a result, we felt that our project carbon accounting was probably missing quite a bit of information. So one of the places that we figured that this was happening was on our 510 studio, which is our new studio in downtown Minneapolis. We went for LBC materials pedal certification, and as part of that, you have to do quite a bit of tracking for things that we hadn't even really thought about capturing on our sheet, because the Framework for Design Excellence doesn't capture all of those things. And we realized that from there are a couple of 2019 reports on CLF, and there's a few different publications and reports we started reading. We realized that even for the process of accounting for embodied carbon to meet LBC, there wasn't a strong enough benchmark in place to really capture some of that interior stuff. So there's work to be done there. So I think that's just a background to say that the work that we're showing is in an effort to capture data on each of our projects more accurately. And this is the revised version of our sheet that does a deeper dive into embodied carbon in interior materials. And Emily's going to talk a little bit more about the study itself.
Yeah, so I'll talk about casework and countertops and how we kind of come up with our embodied carbon numbers. We first started thinking about it when we rolled out that interior G sheet that Simona just showed you, the last slide, where we were trying to focus on renovation projects where we weren't touching, a lot of the structure and exterior facade, and just seeing how we could get those numbers more closely aligned with what our actual impact is. So this is a multifamily housing project that was 13 stories of an existing building. And when we started filling out our G sheet for that, we realized that a lot of the stuff that we were touching is millwork, kitchen, custom cabinetry within bathrooms. And there was really no way in Tally, like we've kind of been mentioning, to calculate that sort of thing. And we figured it would probably be a pretty high number in a project like this. So the left is showing you what you already know, which is that Revit has, all these different family types, and Tally does not pull from the casework type at all. So we needed to come up with a workaround. So what we did was model upper cabinets, countertops, base cabinets, and tall cabinets. And what we did was use flooring and wall types to create like a fake upper cabinet countertop that Tally could pull information from based on the square footage of the material. So what we came up with was we wanted to try to test and compare different materials against themselves, so that when we start the design process, we have a better understanding of where we should be starting versus just, you know, counting it at the end of a project. We wanted to be able to make decisions easier in the beginning. So we compared these 8 different base cabinet types. So we have linoleum, plastic laminate, wood veneer, plywood, cement particle board, a color through wood fiber board, which is basically like a color through MDF. We have a solid hardwood and an OSB. And then you can see within all of these different pointer things, these are all of the different substrates that we assigned in Tally as well to make up the components in the asset part. And then for our countertops, we did 10 different types that you see here. And then some have a MDF substrate. We applied, you know, PVC edge banding to the ones that is applicable, or, you know, exposed in certain instances as well, based on what we typically see. When we got all of that data back from Tally, we've graphed it all out, and this is sort of our findings. You can just kind of compare them against each other and see, you know, which ones are super high. We had a lot of different things where we're like, wow, wood veneer, crazy, super high. And we need to like look into that to see, you know, why exactly that is. And it's mostly probably because of glues and things like that, adhesives, not being able to readily use it, and probably the waste that it, if it's like a rift cut or something like that. We can dive into this a little bit more, maybe on the next page, the biogenic, Simona, or no, okay, here. We'll talk about, so from our findings, we wanted a way that we could easily calculate this for projects going forward, so that we could, you know, just calculate at the end of our project, or maybe make a budget, a carbon budget for ourselves in the beginning of projects. So what we did was take all those numbers, create different calculations. You can pick down in Excel which countertop you have, which base cabinet type you have, and then just do a quick lineal takeoff. Type in your lineal feet, it converts everything and gives you your total coefficient or carbon per square foot. So yeah, so then we want to talk a little bit about some of these bio numbers and how that could be taken into account or not.
Yeah, so, and I think this is kind of, we worked with materials available in Tally pretty much as they were given, but the one assumption we made was the assigning of biogenic carbon, which you can choose as a click box in Tally. And this is a thing that I, you know, we're open to feedback on, but the assumption I made was if a wood product is harvested from responsible forestry practices like FSC, then you can account for biogenic carbon, or the sequestration of carbon from using wood itself, because it is a sustainably managed forest. If it's not a sustainably managed forest, kind of the knowledge or wisdom that I've kind of heard from the industry is that it's hard to account for biogenic carbon from unsustainably managed forests. So choosing bio versus non-bio is why there are a number of different results for different like background sourcing of wood in our results. And yeah, I think something that was just really interesting for like countertops, we were bummed to learn that solid surface was such a high embodied carbon product, because it's something we like a lot as far as durability and aesthetic, and kind of the ability to use it in a lot of different ways and contexts. On the other hand, we were kind of surprised to see that concrete actually, you know, we double checked this. Tally seems to be doing the takeoff and the calculation right, but concrete is actually really low by comparison. And our kind of takeaway there is that in structural uses, you're just using so many orders of magnitude more volume of concrete that's why structure accounts for so much, whereas a countertop is such a thin piece that actually in this application, it's surprisingly low.
I will add in for the color through MDF, we did alter the tally based on, a spec that we use, and alter the shipping distance because it is manufactured in Korea. So we did, look kind of like Alex was talking about, like around to see if they were pulling right, because the original MDF, when we were thinking about it, was way lower than we thought it would be if it was manufactured in Korea. So we sort of like, changed some things around based on what we were finding. So we have posted our research on CLF, and we're always open for feedback and just having conversations about this. So if you have any comments, please bring them our way.
Yeah, I'm just posting the links in the chat here.
Okay, cool. And then one graph that we wanted to show is when we started doing these with our bigger, condo projects, we realized that the casework is actually accounting for 1/3 of our interior carbon, which is a ton, way more than we were actually thinking it would be before we did the study. So that's on the right side graph. On the left side graph is our office project, where there's not, a ton of case. We have a large kitchen and a bunch of built out kind of custom millwork pieces, but it's still like a very low number in the context of an office project. But what we were concerned about when we saw this graph is the furniture. So Lauren actually is going to talk a little bit about how we calculate carbon for furniture, because it's actually consuming a lot of our number here. Yeah, this is actually a graph where we, for LBC had to calculate what we're salvaging, what we're not, what we're keeping. And our salvage task chairs came out so high, 15,000, that we were like, okay, we have to take a deeper dive into this. That is way higher than we were expecting it to be.
And that was calculated by weight, correct,
yes,
Emily?
weight.
Yep.
Yep.
Yeah, at the time. So yeah, thanks, Mona. Yeah, so like Emily was saying, the reports that we were seeing on the relationships of furniture and the overall building's carbon story, we identified this was a large quantity of carbon that we weren't able to track or quantify through the regular means of carbon calculations like tally. We had a lot of internal discussion on carbon budgeting as well at this time, and how you can proactively work through each project phase to reduce the overall carbon of the building. So that's one thing we were identifying with furniture as well. It's something that can be tracked early on in the project and actively worked towards, reducing the overall carbon impact of the furnishings. Let's see. So yeah, so in efforts of reducing the carbon, components that exist inside, which resulted in our GWP calculator, like Emily was mentioning, for furniture found in the sustainability tracker. That's just part of that package that we've been mentioning, that has our G sheet and other sustainability metrics trackings. I'll introduce that to you all now. So our hopes with this calculator are to track carbon in the early fit planning stages, like you're seeing on the left-hand side of the screen here. Encourage the reuse of existing materials and furnishings, and advocate to furniture manufacturers to optimize furniture assemblies, like we were seeing in that previous slide about like that steel case think chair, designing for disassembly so it's easier to salvage those items in the future. You can go to the next slide, Simona. Thanks. So this is a snapshot of kind of the brains within our GWP calculator for the furniture. On the left-hand side, you'll see we started this project out also in partnership with the U of M. It's an architecture grad student, Java. Niamjav, she started pulling together different EPDs that we could create averages of for all the different furniture types that you're seeing on the left-hand side of the screen here. So conference chairs, task chairs, stools. These are a lot of typical things that we saw we use in libraries as well as other commercial spaces. So what's not editable in the document, it's locked, but the EPD1, EPD2 and 3, that information is locked, but that's averaging the global warming potentials that we found for each piece. And also that far right column is mentioning we were using the CLF baseline where possible or when it was available. One last thing to note on this at the bottom, we, of course, doing so many libraries, we were always curious about like the carbon impact of all that steel and welded shelving. So we, similar to the Casework study, the shelving was modeled in Revit and then calculated in Tally to get those numbers that are seen there. You can go to the next slide. So it's an expanded view. So we've seen the first two where the green and the blue highlights are. So entering the quantities of furnishings. So the far left again is that list of all the types with some notes just talking about typical finishes found in that configuration. Thanks, Mona. And then to the right of that, you see the information where you enter the quantities of like how many new task chairs versus how many salvage task chairs. So this is also hopefully encouraging people to always be checking against like what can we salvage, what must be purchased new, because once you go kind of over the brain of the document that you don't edit information in that has those numbers from the EPD on the far right hand side, that's where the calculations start happening and totaling at the bottom right. That gives you the total GWP of the new versus salvaged. And then following that dashed line, taking up to the top left of the document, that's just where that's home to give you that overall snapshot of the furnishing for that project, both new and salvaged, and then the number combined. Lastly, we know that whole list is obviously not exhaustive of what the whole furniture industry and world and what's out there. So there is a portion on the bottom left of that Excel worksheet that gives you a just space to itemize other pieces that you're purchasing new that maybe didn't fit any of those descriptions above or salvaged. Just continue to track that information. And maybe as you get an EPD for that specific piece, you can enter that in the lines above, or just track that information and advocate, like we've kind of been saying throughout this whole conversation, advocating to manufacturers, furniture manufacturers especially, for that information, for that EPD data, because they're definitely farther behind than other material industries.
Yeah, so I guess just a couple of, I wanted to mention that these calculators we've been talking about are available for download on our website. We essentially took the framework for design excellence, like the Common App, and broke it and modified it and added some new calculators to it. So it's a downloadable thing in case you want to play around with it yourself or adapt it in some way. Or do those linear foot takeoffs to do your own calculations. And that's all available on our website at msrdesign.com/generative-impacts. And I think another thing worth mentioning is this recent Metropolis toolkit. Would you guys like to give a little brief overview of that?
Sure.
Yeah.
So yeah, go ahead, Emily.
No, I had my mute on. So we were also involved. It sounds like some other people on this call might have been involved as well. In the climate toolkit with Metropolis, we broke out into different groups and just met every 2 weeks, sometimes a little bit longer than that, and had lots of discussion on how we can change, interiors and carbon and make resources for people who may be starting this from the very beginning, or for more advanced users. But it's a large document, and Lauren and I were both on the team for discussing, and actually a lot of our work for our calculators and G sheets are linkable in that climate toolkit as well.